Hello, my project is titled Earth Sheltered Community Habitat for Urban Ecological Regeneration. This project explores how Earth sheltered architecture can respond to future high density urban living by combining buildings, landscape, ecology, and community space into one regenerative system. This design brief responds to the lack of green, sustainable, and human-centered living environments in high-density cities. Instead of treating buildings as isolated objects, my project proposes an earth-sheltered urban habitat as ecological infrastructure. It combines green roofs, semi-underground spaces, daylight wells, rainwater collection, productive landscapes, and shared community paths to reduce heat, support biodiversity, and improve well-being. The project is connected to SDG 11, Sustainable Cities and Communities. The core problem is that high-density urban development often replaces ecological surfaces with hard infrastructure. This increases urban heat stress, reduces biodiversity, and weakens everyday contact between people and nature. My design asks how architecture can move from consumption toward urban repair. I explored three possible site directions. The first is an urban park edge, which tests the connection between city park, slope, and ecological continuity. The second is a campus or civic site where sustainability can become public education. The third is a dense residential block, which directly addresses heat, limited green space, shared amenities, and everyday well-being. This stakeholder map shows that the project is not only for human users, but also for ecological systems. The primary users include local communities, public visitors, tourists, landscape designers, and ecological consultants. The wider stakeholders include vegetation and fauna communities, the World Green Building Council, and the SDG framework, which provide ecological and sustainability guidance. My design methodology combines three approaches. First, speculative design helps me imagine what buildings should do in climate-stressed cities. Second, architectural section is used to test earth, roof, light, ventilation, and public space. Third, ecological systems thinking treats roof, soil, water, and planting as an integrated urban repair system. The first precedent is Earth House Estate Lettenstrasse by Vetch Architecture. This project shows how housing can be embedded into the landscape rather than placed on top of it. It uses earth-covered forms, roof windows, hidden entrances, and shared outdoor spaces. For my project, the key lesson is to integrate building and landscape while using earth cover for thermal comfort and ecological connection. The second precedent is Across Fukuoka by Emilio Ambash. It responds to the conflict between profitable urban development and the public need for green open space. Its stepped garden roof extends the park vertically and gives land back to the city. This precedent is important because it shows how a large urban building can become public landscape and ecological infrastructure. The third precedent is Mosgard Museum by Henning Larsen. The museum grows out of the landscape through a sloping grass roof, which becomes a public surface for walking, gathering, learning, and seasonal activities. The section also organizes the interior as a terraced experience. This precedent shows how roof, section, landscape, and public use can work together. Experiment 1 focuses on daylight and section. Because earth-sheltered spaces have limited side windows, daylight needs to enter through roof openings, linear skylights, sunken courts, and central atriums. This experiment tests how light can reach deeper underground spaces while improving orientation, atmosphere, visual comfort, and well-being. Experiment 2 studies earth form, cut and fill, and massing. The aim is to shape the building through the terrain rather than placing it as an object on the ground. By cutting into the slope and reusing excavated soil as roof and landscape, the project reduces visual impact, supports thermal buffering, and creates accessible public terrain. Experiment 3 focuses on green roof ecology, water, and biodiversity. The roof is not treated as decoration, but as living ecological infrastructure. It combines rainwater capture, deep soil zones, planting diversity, habitat corridors, filtration edges, and irrigation reuse. This experiment shows how the roof can support microclimate, biodiversity, water management, and environmental learning.